Okay, so next is function pointers. So your function pointer is so basically let's understand how functions are stored in the memory. So whenever you define a function, every basically each instruction is stored in the memory, right? Similarly, functions are nothing but set of instructions, correct? So let's say this is first instruction, this is second instruction, this is third instruction, like that. There are several instructions inside a function. So a function, whenever you write the name func, this name behaves as pointer. Pointer to what? Pointer to the first element, first instruction address, basically. So this instruction is stored in a memory, right? So it will have some address. So it will store the address of that first element. That's it. So the name itself points to that address. Similar to the concept of ARR, it doesn't require any space. It's just a symbol that represents the address of A, right? So this is what functions are. So if there is some address associated with function, then we can assign a pointer to it, right? We can play with that pointer. So how function addresses? So let's make a function prototype first. So it is int func, then arguments type, and whatever the arguments you are passing to it. So this is my function prototype, right? Now, if I want a pointer to point to this function, so now whenever I create a pointer, you know that it will be created in a stack from our previous discussion. It will be a normal variable that will be created in a stack, and its size will be depending on the width, address bus width, basically the address size, and each address is of 32-bit in a 32-bit architecture system, and each address is 64-bit if it is 64-bit architecture system, and similar goes for 16-bit architecture system. So mostly we are talking about 32-bit architecture system in case of embedded. So we are considering this the address of is will be 32 bits. Okay, so let's say in int main I want a pointer to point to it. So how to create a pointer? So normal variables, for a normal variable, how we create a pointer? We write the data type and we put a star and we put the pointer name. So this is my pointer name, and we assign some address to it, right? Address of it. Let's make it p. Okay, p is your pointer. Similarly, for addresses also we have for pointers to function also we have to give some data type, right? So that's how we give a data type int, then instead of function name. So how normal variables are declared? Int x equals to something, right? Just if you place a small star here in the front of variable name, that it will become the pointer to that variable, right? So if we create a fp and put a star in front of it, then it is my pointer declaration to the function, and in front of it you just have to give the data type. So note there are no data types here. You just have to give the prototypes of the data type, that these are the data types that this function is going to represent. Now you can simply do assignment, give it address. Right now it is a null pointer, right? It is a wild pointer, not a null pointer. You can simply give it an address of func. That's it. You don't need to use ampersand here, because similar to the concept of array, function itself will decay to the address of the first statement of that particular function, right? So you don't need to put ampersand here. Let's look here in the memory. So what I have done is I have made four functions here: multiply, add, multiply, divide, and I'm returning based on the type of function. Now we'll call these functions using pointer. Okay, so I have declared a pointer, and initially I have initialized that pointer to point to my add function, right? So I've just assigned add to it. I've not put and here, right? And operator not here. Address of operator, because and operator itself. This is address itself, right? This is So now if I call this function, it will take these variables and go to that address and call that function. So right now this fp pointer is having the address of this particular function. So it will take these variables and it will go to this address and execute. That's it. So if I run this, similarly, I will update this pointer to some other value sub, then I will call the same function like that. So these how things work and these are your answers that how my function pointer works. Okay. So yeah. Huh. One more thing. This is a very let's say you want to make 10 function pointers, right? So rather than doing this, you can make a type def of it. So I can do a type def star fp underscore t. This is just a naming convention. This naming convention represents itself that is a function pointer, and underscore type means it is a type that to that function pointer, right? So int and bracket int comma int. That's it. Nothing I have to do except this. Now instead of making this prototype, I can simply use fp underscore t fp. That's it. Some error is there. Maybe a semicolon will come. No, with type def, I don't think semicolon comes into picture. Although, anyways, let's see. Oh, okay. With type def also, yeah. So with type def, semicolon comes right because whenever we do struct type def struct that kind of thing, and inside we have the definition of a struct, and in the end we give it a name and put a semicolon. So semicolon is necessary. So yeah, okay. So you can see this is properly working. So rather than declaring every time, you can simply use fp. But yeah, these types should match. The return type and whatever you are passing through them should match. So yeah, this is a basic idea about function pointers, although it is not that much used here. In case of embedded system, only one application of it is callback. So try to study it yourself, but I don't think you should go into that much detail. Just remember how to declare a function pointer. That's it. It might be asked in your interviews. So this is important. Only this line. Yeah.